just enough to make you smile, and you need me to hold you close, and all your fears that you dream of will disappear and flutter on. Whoa, hold on just a little. We'll meet right here in the middle ground is where we'll stand. Let go of the riddle, 'cause you'll find life is a riddle that we're not meant to understand. I'm so just look on, and I'll look down, and all your fears around the ground. Then you said, all I ever wanted was to love like this. All I ever needed was to feel like something more than a closed door flat on the floor. I can offer so much more. All I ever wanted was to feel at ease. All I ever needed was to get up off my feet. 'Cause I believe. Hold on just a little. We'll meet right here in the middle ground is where we'll stand. Let go of the riddle, 'cause you'll find life is a riddle that we're not meant to understand. I'm so
So hey guys, we're here in my room, and basically in this video, as you've seen, I did some of the last stuff to repair the frame. So just what even was it? I forgot. But yeah, the thermostat mounts, I think, and the throttle junction box mounts. So once that's done, now like I've basically I've just done a couple of things. So as you would have seen in the pictures, I've basically got those brackets for the lower fairings, because you can't really find them anymore, and they're quite expensive new. So I got these second-hand ones. They're kind of rusty, but the threads are fine. So I put those on the lower, the cradle. Those were 20 quid. Then I got this little air intake rubber thing that goes on the fairing behind it. So that was another 20-25 quid. But yeah, so in this past week, what I've been doing on the project has been not really stuff to the chassis itself. It's more like extras. So basically, I just realized the project was just becoming like a bunch of parts that I was just buying off the internet or the catalogs and stuff. Yeah, and that's not really the direction I wanted to go in. So when it got to this part, which I had been saving for quite a long time, this is the 84mm Brembo rear caliper bracket. So I already had the caliper. I got it for 25 quid off eBay, and this was basically the caliper bracket that you have to use to mount that brake caliper. Now I got the money. I'm selling like clocks on eBay and stuff, so we sold quite a few in the run up to Christmas. So I had the money, but like I just didn't want to order it, because now that I have the money, I could sort of realize that, you know, I could make this part if I wanted to, and even if it would probably cost more than it does to buy one from Tiger or Jap 4 Performance in this case, then it's just like anyone can go out there and look at a parts catalog online or go to this website and buy some trick stuff. So if I did that, that would be a bit boring. So instead what I did was I sort of I got my original sort of brake caliper hanger. So got the dimensions for the spacer bit over here, so the diameter, which is 38mm, the thickness, which is 30mm, and then the inside diameter of that hole, and then got that the dimensions of that sort of what do you call it, that flange, or that sort of arm that stops it from rotating. It slips into like a little I don't know the word, but it basically clips onto the swing arm to stop it rotating and keep the caliper stationary. So I got those dimensions, and then after that I sort of looked at these pictures, and I was guesstimating pretty much for the dimensions of these holes and the shape of it. So obviously the distance between these two holes is 84mm, and it takes an M8 thread. That the caliper itself is non-threaded, the mounts on it, so the threads have to be inside this hanger. So they take an M8 thread. So what I did was I sort of got the 84mm and the M8 thread basically done, and I sort of came up with like a little CAD model. So as you guys know, I was doing mechanical engineering at university. So what I did, here we go, I tried it a few times, you know, just to get it right. So here's my model. So the way I did it was, you know, like I said, I made that in the center, in the origin, and then I create this, and then afterwards I sort of if you look at the first drawing, you can create the shape of that metal with along a profile. Why isn't it focusing? Come on, there we go. So that was a profile I chose. So this offset basically is to get it in line and behind the caliper, so that you can thread the bolt through the caliper and onto the thread inside this hanger. Sorry, it doesn't like this white screen, so let's stop that sketch. So yeah, once you did that, you can then just extrude or make the material over there, and then I used another drawing to, let's have a look. Yeah, that was the drawing to extrude it, that shape through that profile, and then that was it's a lot easier to make a sketch before doing the holes. So I just made a sketch of this point to this point, 84mm line, and then you can accurately place those holes, which you can thread as well through Fusion 360. So this Fusion 360 program is probably one of the best CAD programs I've used. I mean, it's very similar to Inventor, which is used more in the industry, but I used to, like when they taught me CAD in university, I used Creo Pro Engineer, and compared to Creo, this is amazing. Like Creo is just so for lack of a better word, shit in my opinion compared to this. So it's just so much simpler and easier to do everything in here, and it's got more functionality, and it doesn't crash as much. And although you have to save your files to the cloud, I think it doesn't really matter. I mean, I've got my little folder on the cloud here of RGV parts and stuff. So yeah, so I did that, and I've basically once you do that, you can have a look. You can save it as a STL and get it 3D printed. So I did that, and I've sent it off to a 3D printer, guys. So here's the volume there. So that's about 71 centimeters cubed. So usually they charge around £1 per 5 centimeters cubed. So this cost me, this part to 3D print, £14 plus postage, which is not bad considering, like, it's quite a large part, so it will be about, I think, 15 by 15, and then by like 40 thickness, or 60 thickness, sorry, because this flange bit, if you look at it from here, it's actually below that, so it needs a support structure underneath as well. But basically for 20 quid all in, I'm gonna get this 3D printed part in a couple of days, and we're going to test fit it on the bike, and if it all fits well and stuff, then I can use this CAD model to get a nice hanger CNC machined out of 70-75 aluminium, or maybe 60-82, depending on costs. But yeah, for now this is just a bare bones sort of CAD model. Once I know that this is fine in the 3D print, I can add chamfers and fillets and make it look nicer, you know. Maybe even add the Project RGV logo or something here, because you can do that by inserting a DXF, I think, was it? Yeah, either DXF or SVG, something like that, and then you can extrude that. So yeah, that's the first little thing that I did this week. So yeah, once I did this, basically, then I sort of kind of changed my mind about using the Nissin calipers up front, because those are the 90mm spacing ones as well, just like the Tokiko, so they're a straight swap. But the condition of the ones I got is not great. They're going to need a rebuild soon. So like I saw on eBay, there was a, where did I put it? Hold on. There was a couple of brake caliper adapters like these for Brembos with the calipers, but these are fucking expensive. So the calipers are 100 quid for a pair at least, and then these adapters, when they do come up for sale, they're about 200 quid. So this lot was selling for 300 quid. So I looked at these and I thought, you know what, I could probably give these a go in CAD as well. So I obviously know that hole to that is 90, that hole to that is 65, but then each disc is different because you have a different size disc. So the one on the RGV, let's have a look, where is that? The RGV VJ22 disc is 300mm. Yeah, it's a 300mm disc. So this could be for a bigger disc for a Gixxer 750 or any other one that uses a 90mm caliper spacing. So I made the model for that as well, a rough model. So here we are. I'm gonna at the moment I've left this extra material up here so that just in case, because this was basically made rough, these two holes were made roughly from that drawing. So this is 90mm spacing, that's 65, and then the angle of this might need to be changed, or the location of it. So that's why I left some extra material on. Or I could just suppress the features of this hole, and then basically I can just 3D print this part as it is, and then just mark up the holes manually, and then edit the CAD model afterwards. So yeah, I made this as well. As you can see on this part, it's actually got it actually like traces the shape of that Brembo caliper. So what I'm going to do is, my dad's RS250, he has Brembo calipers like these. I'll borrow them off that bike for a bit, and then on the 3D print I'll trace out this outline from where I can add all this material here, because what that will do in the end is that will obviously, wait, let's orbit, because I can't hold shift at the moment. So I'll add that material all around here, and what that will do is I'll be able to remove a bit here to make clearance for the caliper, but then it will thicken up all these surrounding areas, and it will be a lot stiffer and a lot more beefy, which is obviously what you want from a brake caliper adapter. So yeah, this will be pretty good as well. I reckon this will be about a tenner to print, even less than what that was. But once I know that those are fine and I edit the models, then I could probably get a large stock of 70-75, give them to like someone at a machine shop, like my local guys, Elstree Precision. They've done a couple of projects for me, so I can do that and get like Brembo brakes up front and Brembos up at the rear. And one other thing, just for Bants, I started doing, because of that website, which this is like lighttech.co, and then USD fork database, they have a lot of all this information you need for disc spacing, triple clamp dimensions and fork dimensions and stuff like that. So if you go here and find your model, so mine is up here, VJ22 RGV, and basically I had the dimensions for fork centers to centers and the fork diameter for the top triple clamp, then you got the triple clamp offset and all that. So I thought, you know what, let's give the top triple clamp a go. So this is my attempt. Wait, yeah, so it's got the same dimensions as the stock one, but it just looks a bit more trick. And yeah, once it's done, then I'm gonna chamfer it up and stuff. But yeah, I could probably use the stock one, but this one, you know, it would be another little thing to tick off the list that yeah, it's got my own custom triple clamp in it. So that would be pretty cool. I still need to sort of hollow it out from underneath and add the 4 threads, which basically the speedo bracket connects to. But yeah, apart from that, I also need to add an ignition switch, but I have to take the top yoke off and the speedo bracket off, and then measure the dimensions for all that mounting hardware. So I'll do that at a later stage. But yeah, so that's what I've been doing in this project for now. So hopefully this will cut now to 3D printed. So just like magic, we have the 3D printed part. So yeah, I sent this off to some guy on eBay who uses an SLS file and 3D printed it. This is in ABS, and I've heard stories about ABS warping upon cooling and stuff, but hold on, let me turn this down. So yeah, I've heard stories of ABS warping on cooling, but this seems alright. Like probably got a heated bed and a heated enclosure. So yeah, it's nice and it looks good, dimensionally correct. One thing is that this hole over here for the axle was it's supposed to be 20. It's around 19.2, so it's slightly undersized. So I'm just you know, just filing it a bit with this file to get it to fit the axle, because I want to put the axle, which is there, all the way through and, you know, test fit it. But everything looks fine apart from one thing where you put the caliper on, and even there's clearance behind the caliper between the disc as well. Just one thing is that the clearance between the actual hanger and those bolts is very close. I'm not sure if they're touching or not. And to be honest, if you look at the design, that curve that comes in there, that can actually be pushed a bit more this way to clear those bolts, and then basically the rest of the design seems fine, the spacing seems fine. I'll tap the holes and fit this caliper properly as well. I'll file this hole out to around 20 so that I can fit the axle, see, and I need to test fit this section as well, which clamps onto the swing arm in a little place, so then just to make sure it doesn't move forward or backward or spin round and round. But it looks good. Let's have a look. I filed down that central internal diameter for the spacer, so I've got it onto the axle and test fitted. So I don't know if I showed you in the pictures or not, but basically this little shape here that it goes like that, that is a bit too close to the disc bolts. So I've already edited the CAD model like 5 minutes ago. It's the evening time now, so basically I've made it come a bit further out before bending like that, and now it clears the disc bolts. I haven't obviously 3D printed another prototype, but that's going to be for the next one. I might not even do the next prototype, I'll just go straight to CNC machining. But as you can see, there is another problem, which is just right now the axle is loose, but as you can see, this little arm, which is like this, it clips on into that thing over there to stop the rotation. But as we can see, this is pushed up all the way against that, but it's still only engaged on that arm by about a couple of millimeters. So I don't know how I got that measurement so wrong. It needs to be shifted at least 2 or 3 millimeters to the right, and there's no need for this extra, so shift the whole thing 2 or 3 millimeters rightwards. In fact, I should probably measure that more accurately. Let me just go grab that digital calipers. Right, let's turn it on and see if we can measure that. This is so dodgy, man. Fucking okay, so that's about, okay, that's more than 3 or 4, that's about 8 mil, so it's 8 mil off there. So if we shift the entire thing 8 mil to the right, then it should be fine. Yeah, 8 mil to the right, so that's what we're going to do. Okay, so there we go, we've got most of the stuff, measurements I got right. I've beefed up the model from here, so this section is a lot thicker. I've moved this out of the way of the disc bolts, and now I can move that 8mm inwards, and then I think we've got it all sorted. As you can see, I got the caliper mounted up to this bracket as well. I couldn't get the wheel in right now, but I'm just looking at this, looking at the angle, so it's going to be about that. This is what I call the tiger angle, so that's underslung just like the tiger caliper bracket. So my plan was to perhaps, if I could, change it so that it's the caliper is not there but it's somewhere up here, so that way it's more accessible, it's away from the dirt and everything, and you can see it as well. And maybe if you do a logo over there like upside down, it would look quite nice. So let me have a look. So that's complete, so that would be 90 degrees, around about there. So it's still accessible at 90, but it's tight. I mean, to get a ratchet over there for that bolt would be tight. So if we do about 100 or 110, it would match up with the swing arm. So let me just have a look there. So that, around about that angle. So that's what it looks like. Just for reference, I might use this video as a reference when making the CAD model. So yeah.